On number 27, it gives you two pieces of information, and it says to find the exact value of each trigonometric function. So it's going to ask you about double and half angles of sine and cosine. So using this, let's first figure out what a triangle is and where it looks, where it is on the unit circle. So we know that secant deals with x. So secant theta equals, remember, it's r over x. And knowing that we have 3, it's actually r equals 3 and x equals 1. Okay, so we know that. And we also know that sine of theta is greater than 0. So let's now figure out where secant is positive because we have a positive 3, and where sine is positive. Okay, so secant is our x's, and the x's are positive over here and negative over here. So secant is positive here, secant is positive here. Sine is positive, and sine is our y, so sine is positive here, and sine is positive here. So in quadrant 1, that's where we will be working. So our triangle will look like this, with a radius of 3 and an x value of 1. So we need to figure out our y. Well, using Pythagorean theorem, we can figure out what our y is. 3 squared equals y squared plus 1 squared. So y equals the square root of 3 squared plus 1 squared, which is the square root of 8. Or, if we break that apart and group them in 2, we know that the square root of 8 is equal to 2 square root of 2. So that is our y. Okay, so now that we know that we're in the first quadrant, which is all positive, we have our triangle with our radius, our y value, and our x value. We can go ahead and figure out how to find the exact values of the trigonometric functions that it asks. So it asks for sine of 2 theta, which is the double angle, and the equation for that is 2 times cosine theta times sine theta. So what is our cosine theta and our sine theta? Well, if we look at our triangle, we can figure that out. Cosine theta, if you recall, is x over r. So our x is 1, and our r is 3. So we have 1/3. And our sine, if you recall, is y over r. Our y is 2 square root 2, and our r is 3. So we have 2 square root 2 over 3. So we can just plug these in and then multiply it out. So we get 2 times 1/3 times 2 square root 2 over 3. So multiply straight across. We get 4 square root 2 over 9. And since we can't simplify that, that is the answer for sine of 2 theta. Now it asks for cosine of 2 theta. Let me just put it up like that. Okay. So now we're asked for cosine of 2 theta. And if you look at your formulas, you will recall that this has 3 different formulas that you could use. There's one that's cosine squared theta minus sine squared theta. There's 2 times cos squared theta minus 1. And there's also 1 minus 2 times sine squared theta. So, which one should we use? Well, I would recommend using whichever one of these is easier, because you see how this one has the sine has the square root of it. It's a little yucky. So let's use one that is very involving with cosine, because it's 1/3. So let's use this one. Okay, So cos of 2 theta equals 2 times cosine squared, our cosine is 1/3, minus 1. So let's go ahead and square that. 2 times 1/9, 1 squared divided by 3 squared, minus 1. I'm going to multiply, and now I need to subtract. And then when you subtract that, you get -7/9. And that is the answer for cosine of 2 theta. Now, what we need to do is we need to do the half angles. So first it asks for sine of theta over 2. If you look at your formula chart, you will recall that this identity is plus minus the square root of 1 minus cosine theta over 2. So, first we need to decide whether we use the positive or the negative. And how we do that is we look at our triangle. Since sine deals with y values, we use the positive when the sine or the y value is positive, and we use the negative when sine or the y value is negative. So since our triangle is in quadrant 1 and the y value is positive, we're going to use the positive. Okay, so now let's go ahead and plug cosine in and solve this. So we have 1 minus, remember cosine was 1/3, over 2. Three over 3 minus 1/3, so we have the square root of, that's going to be 3 minus 1, 2 over 3 divided by 2. It's yucky. So finally we get to the square root of 1/3. We now need to apply the square root to both the 1 and the 3. So we have the square root of 1 divided by the square root of 3. And since we can't actually take those square roots, let's rationalize by the denominator. So we get the square root of 3 over 3. And that is the answer for sine half angle. Let's also do it for the cosine half angle formula. The cosine half angle formula is cos theta over 2 equals the plus minus square root of 1 plus cosine theta over 2. So we again need to figure out whether we use the positive or the negative. So we look whether cosine is positive or negative. Cosine is negative over here in quadrants 2 and 3, and cosine is positive in quadrants 1 and 4. Since we're dealing with quadrant 1, our cosine is going to be negative. It's going to be positive. Positive. So now let's go ahead and plug in our cosine theta into the equation. Remember, cosine theta was 1/3. We can reduce, and this becomes a 2, and that becomes a 1. So we have the square root 2 over 3. Applied the square root to both of the top and the bottom. Square root 2 over the square root 3. Let's rationalize. So you can multiply these together, and you get the square root of 6 over 3. And that is how you do the half angle for cosine.